1999, I was, fortunate to have experienced a 7.3, 7.4 and it was a rather unique event. Slept through most of it because it lasted all of about 30 seconds. But in 30 seconds, there was massive devastation throughout Turkey, and we had 17,000 casualties. All of this is related to plate tectonics and the movement of plates across the surface of the earth. I mean, this lady is literally carrying ID cards for her family members that are lost and probably buried in this rubble. Being in that area, I also had the opportunity of serving or working with a relief agency for a period of time, trying to get folks out. And the one thing that stands with you is not only complete devastation, but the smells that develop over a period of time because of trapped bodies within the mangled mess. And literally, most of the individuals died because this happened in the early morning hours, 1 or 2 o'clock in the morning, can't remember which. So most folks obviously were indoors and fast asleep. And again, it was very short term, less than 30 seconds, bam, it's over with. And literally buildings collapsed where the upper stories ended up on ground floor, and individuals then obviously trapped within. Turkey in that area of the Mediterranean is a common region for earthquake activities. Some of the earliest volcanic studies were done in that region. And today's lecture, what we're going to look at are the landscapes that develop because of divergent, convergent, and transformed plate boundaries. We started this last time, we didn't get very far, and basically what we will be looking at are these landscape features. Folds, faults, earthquakes, and volcanoes. Of these 4 activities, folds, faults, earthquakes, volcanoes, folds are the only ones that are restricted to convergent plate boundaries. So whenever we have folding activity, it means that literally the plates are coming together. And folding activity will take rock units that may be horizontal rock units such as this would be sedimentary. And when we have compressional stress, and that's what's here, stress is going toward the center of this, and with compressional stress, literally the rock units will be folded up into a series of structures like this. Rock units exhibit 3 different characteristics when exposed to stress. One is plasticity. In other words, it can be bended, it can be folded, it can be molded with the stress applied slowly. Plasticity in rock units only work if the stress is slow over long periods of time. Then we have elasticity, where the rock units will literally vibrate, will break, will vibrate, and literally try and reorient themselves. We'll get into elasticity a little bit later. And finally, rock units are brittle. They'll fracture if exposed to stress too rapidly. Think of that silly putty that you played with as a youngster. You take that silly putty and pull it away gradually, and it literally stretches out, stretches out, stretches out. Put it all together again, and then pull it apart rapidly, and what happens? It breaks right away. the amount of stress applied to a rock unit will determine which of these three characteristics will develop. So slow pressure over time results in plasticity or plastic-like activity. So whenever we have compressional stress, rock units will exhibit this high degree of plasticity. And when this happens, we have features that geologists identify as anticlines. Anticlines are these high points. The rock units slope away from the axis. The anticlines, the rock units slope away from the axis. And then the low point, the valleys, are referred to as synclines. And the rock units in this case slope toward the axis. So a series of anticlines and synclines over a period of time. At times, the stress can be so significant that literally these folded structures will exhibit almost vertical displacement. So, again, slow pressure over lengthy periods of time, and you can get these rock units to behave like they're a fluid, literally. And if you drive through some of the back roads of Wisconsin and look carefully, you're going to find this kind of orientation. Okay, folds then represent displacement without fracture. Fracture means that the rock units have been broken. Displacement without fracture. Faults, however, are displacement and fracture. Faults cause earthquakes. Faults cause earthquakes. What's an earthquake? Okay, a release of energy which results in vibrations on the Earth's surface, more or less, right? Why do we have these? Why do we have these vibrations? What's causing vibration? Okay, the vibrations are caused by elastic rebound. Elastic rebound. Now I'm going to ask Reeser to help me out. Can you do that? And put it on the top of an arm and a leg. Hold on that end of it. Oh, right here. What would happen if I hold it down? Hold it down. Hold it down. What would happen if I put a lot of stress on this? It's going to break. It's going to fracture. The term in geology is fracture, not break. Okay, this is going to fracture. So we can put a lot of pressure on this if we do it slowly. And we can get this thing to really bend. But if we put too much, you're supposed to hold this up there. Okay, put too much in, it vibrates. Hey, we should, anybody have a meter stick? That works better. Yeah. You only have that. Okay, hold it again. What normal, hold it tight. Okay, what's going to happen is this, close to the edge, half of you help, and over on the edge of the table. Hold it tight. Okay, well, a meter stick really vibrates like crazy. This thing doesn't. When the rock unit breaks, this rock unit that was bent like that is going to rebound So it tries to orient itself to the original